All right, here is a simple two-dimensional static equilibrium problem, okay? So we are trying to figure out, assuming that this is something that's hanging, right? So I would say that this is some kind of a mass. What is this force here, and what is the mass of the box? All right, so it's very, very important that you follow all of these steps, all right? So the first one is going to be to just draw the free body diagram or the force diagram, okay? And I'm just going to call this FT because it's probably some kind of rope, okay? And then I'll call this FT2, maybe FT1, and then this would be FG, okay? Sometimes in AP, they want you to label that MG for mass times acceleration due to gravity, so we'll see. Okay, so the first step is you want to try to draw your force diagram or your free body diagram, all right? And the second thing you want to do is split into components, all right? So then I just want to look at this FT1, all right? And I want to split this into FT1X and FT1Y, okay? So do you see now we've kind of done away with feeler-dealer labeling for the moment, right? Because this is just one simple picture. It's more of a calculation than a conceptual question, okay? And if we put all those labels, then we're just going to be confused, okay? All right, so if this is 45, right, I can see that my actual triangle is going to look like this. Oops. Okay, so I have my FT1Y, my FT1X, and then the whole thing on the 45. Okay, so I have FT1X is going to be FT1 cos 45 and FT1Y, FT1 sine 45. Okay, and I'm just going to leave them like this for a minute. If you know the number like here we do, we can go ahead and get values for those. Okay, but I'm just going to leave them for just a minute. All right, now here goes the third step. This is the most important thing to do. And you really, really need to do this and not skip it, okay? This is what's going to really help you. So you're going to have your mass, and then what I want to do is I want to redraw this force diagram with the components instead, FT1X and FT1Y. Okay, so I'm going to redraw it with the component. So this is the exact same picture as 1, but instead of this FT1, I'm writing it as its components instead. Okay, don't write both of them on the picture. That would be incorrect. Okay, but one or the other. All right, and it's really important that you do this step because this is going to help you sort of solve it out. Okay, all right, then let's see, how do I want to do this? All right, so then we're going to set up an equation in each direction. So we're going to say the sum of the forces in the x direction is going to equal 0, meaning they're balanced. And the sum of the forces in the y direction is going to equal 0, meaning they're balanced. Okay, just like in projectiles, you need to set your positive. All right, and there's a couple different ways to do this. I kind of like to just set the picture, set the negatives by looking at the picture. Okay, but really what you're doing is you're summing the forces, right? So I would say FT1X, okay, it's like I'm adding a negative FT2, right? Because FT2 is facing the other direction. Okay, equals 0. So normally when I do this, I would just write, oops, T1X minus FT2. I would just write it like this. I'm going to say everything in the positive minus everything in the negative, and then your answers are just going to come out positive, kind of like an absolute value. Okay, you can track through the negatives if you want, but it's usually pretty easy this way. Okay, so FT1X equals FT2, which is what we're trying to find. Okay, so now I know that that was FT1 cosine of 45. Okay, now I'm going to go ahead and plug in my values. 600 newtons times the cosine of 45. Okay, so that leftward pulling force is, I have to have a calculator because that's a radical 2. Oh my gosh, this calculator's so slow. Where's, oh, here, I have an actual calculator, that's better. Okay, so 600 times the cosine of 45, make sure you're in degrees, is 424. I'm just going to round it. Newtons. Okay, so that would be that leftward force. If I do the same thing in the y direction, I'm going to do everything facing up minus everything facing down. Okay, so I'm going to see that my FT1y equals my FG. All right, and if you want to, you could FT1 sine 45 Okay, you can find the FG first, or you could substitute in the MG at this point, mass times 10 newtons per kilogram. Okay, I'd probably go ahead and do it that way just to practice with the variables. Okay, now I'll plug it in, 600 newtons times the sine of 45. I'm just going to use 10. Okay, because then I'm going to get the mass in kilograms. So that should be the same as the other one. So this is going to be 42.4 kilograms when I plug all that in. Okay, so that's a simple two-dimensional problem that just has one easy force to split up. Everything's balanced because it's hanging at rest. But this process is very important. Okay, so please redraw the picture, okay, as I showed here. Okay, and then you need to set this up. And sometimes on the AP test, like, you may get a point for saying that, right? So make sure that you actually say that instead of just jumping right in and start putting stuff in, especially don't put numbers till the end, okay?